Welcome you all back to the 10th session of the FDP on Responsible AI. It's a great honor to introduce our esteemed speaker of today, Dr. Somasundaram, Head Digital Transformation, LG Equipments Limited. He completed doctorate in business administration with a specialization in data science from Swiss School of Business and Management, master degree on data science from Liverpool John Woods University, executive management development program on data analytics from Indian Institute of Management. His achievements are bagged Managing Director's Excellency Award for the technical contribution toward organization goals, received Managing Director's Excellency Award for active involvement in project completion, awarded 14 times Star of the Month, awarded 4 times Star of the Quarter. He's currently working with digital transformation as head, LG Equipments Limited. He has worked 8 years in St. Gobain Glass as a team member in the manufacturing unit. He has worked 2 years as assistant manager and 3 years as manager at Amalgamations Valeo Clutch. He has worked for 7 years and ZF Wind Power Coimbatore Limited, where he has worked as a manager in the Department of Digitalization at the same company. He has worked for 3 years as a team leader at digitalization at Siemens. He's a senior member of International Society of Automation, life member of Association of Energy Engineers USA, member and National Secretary of Indian Association of Energy Management Professionals. And adding to it, we are very proud to say that he's one of our expert member in the program advisory committees regularly, and all his feedbacks have given our students to enrich their knowledge in the curriculum every time whenever we update. We are very happy to have you here, sir. And now this session is to you.
Thank you, Professor, for your kind words. So, Professor, I think we are talking about responsible AI and other aspects, right? So, what I will do is I will share some of the case studies which I have worked in my earlier organization, and from there, we can take some leads and move forward. So, before going there, this is only an introduction session. Probably, you researchers can get more information about the projects what I have done from my ResearchGate profile. I'll also put this in the chat. Eagerly looking forward to connect with you all in ResearchGate. So these are all my research works. I would say like maybe not formally, yeah, kind of yeah, academic research, but some of the professors who have worked along with me have helped me to do this particular work in accordance with whatever the journals set standards are. Post having some publications and other things, then I thought like taking a lot of time to document the articles and other things. I thought like, okay, we should not waste time, rather share as much as possible from the industry so that academic people can take it and move forward. So one of the effort what I have taken is um, in a manufacturing um, industry, there are multiple departments. Okay, so these multiple departments, they have to work together. So these multiple departments, if they have to work together, there has to be a common understanding, and there are a lot of AI use cases, and one AI use case for one department cannot be given to another department because their problem is different, their data is different, the people's skill level of that particular department will be different. Say, yeah, R&D department using AI, an IT department using AI is different from probably a HR department using AI or a manufacturing department using AI. So there are a lot of challenges. Okay, so this is the research what I did. I'm just opening it directly from my ResearchGate repository, so you don't have to probably ask for any PPTs and all from me, so you can directly get it from here. So, researchers, what probably would be a takeaway for you is starting from product development, design and development, how the manufacturing is getting planned for whatever design is done, and how, if the products have to be produced, what are all the different machines needed, and that machines how it has to be. So those things comes under the manufacturing engineering field. And finally you are having the manufacturing execution. So it's more design or plan, then how to manufacture, plan that also, put it into practice, create a machines and other things so that you can produce that particular product. And you have to continuously produce with high efficiency, so that comes in the manufacturing execution piece. Now, with these broad functions, if I go into multiple departments, there are six major functions in product design and development. Under that six, there are 66 subfunctions are there. These 66 subfunctions are doing 300 plus activities. Now, the research is each and every activity, what is the AI aspect which can be brought inside? If the AI aspect is brought inside, what challenges they will face and how it can be mitigated. This is on the product design. Similarly, for planning, similarly for engineering. So you can see like almost close to 600 activities, how AI can be used and what challenges people will face and how it can be mitigated. So that is the research is available in my thesis. Because many times when I am speaking with professors, they will say like, "Sir, give us a problem area." So now you can see like at least 600 problem areas there for you. And each and every activity, there will be multiple use cases also. So I'm not counting those use cases. So for your students also, you can give this as a kind of a research work for getting some problem areas for their projects. When I did this particular research, there are huge amount of literatures have gone through, and this is in Swiss School of Business, so they have very stringent literature review, and their committee, probably in anonymity and other things. At least you have someone as a known supervisor. Even my supervisor itself is a Russian, and she is doing her teaching in Swiss school, and the doctoral committee has another three experts. So that's how it was. Very stringent, but I really enjoyed it. Finally, as a crux of the work, what we have done, whatever research we were able to do it, it's more, I would say, a secondary research, and the primary research is more about arriving a questionnaire from the secondary research and then going into industry experts and bouncing off whether is this really matching to what challenges you are facing or not. That is how it scaled it. And when we list down all the challenges, it can be probably bucketed into six major areas. The first area is lack of skilled workforce. This is a very important problem. Many people say like, okay, data science, data analytics kind of topics are even there in school. It's very good effort that is very much needed. People should understand the different type of analytics and how it had to be taken forward at a very earlier stage. The second biggest challenge in my research, what I'm able to see is there are AI algorithms, there are R, Python kind of software tools, but how this can be connected to the existing system. My existing system is of a different platform. This is a different platform. How I can connect? That's the another big problem, which is there, and it is stopping the implementation of a very good use cases. Third is Yeah, now I know that this is something which is doable. I can also integrate it, but I can do it for one machine. But if I'm able to, if you want for say 100 machines, then there is a problem of scalability. I will not be able to scale it. Majority of the time, this is because of the design of initially how people have convinced, or sorry, how people have ideated that particular AI use case would be. And when they think about it, they were thinking about only one system. When that one system is becoming 100, they are getting a challenge because of infrastructure. You need, high computing powers, probably sometimes, good network connectivity and other things. I have grayed out this privacy and security concerns, or I would say like a light touch to that, because this is something was there for ages. It's not new. Data theft, data going to someone else. It's an age-old problem. But now there are stringent things which are come into place. There is law which is also helping us to block it. Second, the service providers are also accountable for protecting our data. So there are a lot of government interventions which is graying it out. I would say like we don't have to probably think more about this. The third important thing is availability of the data, especially in industry. That is a very big problem. Data is not available, and the data, if at all it is available, it is in an unstructured way. It's very hard to process it. I told like it is unstructured. That also means like a CNC machine's data from a Fanuc system is different from a CNC machine data of a Siemens system. One company is collecting a data in one way, another company is collecting the data in other way. They are calling it this way, they are calling it this way. Pre-processing is becoming another big problem. They process some data with some algorithm, some standards, and another company is processing it in another standard. So these are all the broad challenges when we finally arrived at the research, especially the literature. And there are a lot of gaps which also came in. So this also probably will be very helpful to you all. See, there is a kind of a culture of a silver bullet. So there is one medicine which can solve everything. For example, generative AI. Hey, generative AI, it can do wonders here. It can work here. It can work there. But very important is each and every department, each and every function, each and every activities within the function is unique. It requires a different kind of customization. So that customization is something is very very important, and that is one of a very good research which people can work on it. Second is there are some departments, okay, but some departments challenges are unique. Some departments challenge we can probably create a cluster, but there are some departments whose challenges are very very unique. Okay. And for that there has to be a, probably we cannot have a silver bullet kind of an approach for the complete manufacturing sector, but at least department wise we can have it. So to that level we can have the research. If not up to functions, we are tailoring it. At least at the department level we have to tailor it. The third important thing is understanding and the direction. Okay, how to implement the data science use cases. See, this is a kind of top down. What is needed for the business, and for that particular need, the AI algorithm have to work. Technically, people will do something, but commercially, what they have done is giving the result or not. That is something very very important, especially in industries. Academics, we can do research and we can for probably publish some papers or file a patent, but in industry, anything without business sense is not so sense. Sometimes they say nonsense also. So business sense is very important. Second is There is a huge opportunity, okay, to understand the gaps, okay, in how the function or the process have to perform and how it has performed. So there is a huge consulting opportunities available. So each and every company is having some problem, and that problem they want to solve it, and people are looking at someone who can come and identify what is the gap, and for that they are trying to give some solution. Now, with all these things coming together, the research committee told like, okay, if these are all the gaps and you have already researched it, then create a playbook in each and every department, each and probably at the activity level, create a playbook like how AI have to be used and what challenges they will face and how it can be mitigated. Can to that level, can you create a playbook with data? That's very important. So each and every use cases, we try to create some synthetic data. Some data are already available. So that is the kind of a research which is done. So there are a lot of papers thing. Finally, this playbook, what I try to create as part of my research is, you can see on the left hand side, it is a very complex road for AI implementation. Probably this playbook will give you a straight way to orchestrate whatever you want to achieve as part of AI implementation. There are some, other analysis also we did how each and every department, the top five challenges and top five mitigations for that particular challenge. So this is also something which will be very useful because many times the challenges are different for each and every department. And I told you like the data security and other things we grade out in the larger picture, but for this particular department, that is a very important thing. That's why we have highlighted it here. Similarly, this is for manufacturing planning. You can see like manufacturing planning, the biggest problem is collaborating with the existing IT infrastructure. That is the biggest problem. And for that, things have to happen. Otherwise, it will be very difficult. In manufacturing engineering, see, when you're talking about engineering, you need to have standardized protocols, standardized processes. This is something was a very big challenge in manufacturing engineering. In execution, very important is you can do, you can produce, you can create some AI use cases, but finally there should be a return on investment for it. So alignment of the AI use cases to the business objective is a very big challenge here. Just because everyone is doing, there are companies who started doing it and finally they spend a lot of money trying to make it a success. Finally the money is gone, nothing is a success. So this kind of a situation is also there. So, as a conclusion of my research, the playbook is something as an output of this particular research which is there. And this playbook also, you can download it from my research data repository. And feel free to, give your comments. You can see here, the preprint is there available here. And the link to the Swiss School of Business repository of thesis that is also available. You can go there. Any questions so far?
Dear participant, if you have any questions, sir, I think it's echoing at your end.
Okay, cool. So now let's go into some, uh, you know, some use cases which you can probably get benefit from the work. What is there in the my repository? This is one of the use case which I would say would be very interesting for you all. Let me just download this so that you all can also view it. also give you the link in the chat so that you can also get it. So I think Surya Madam gave a very good introduction about me. So this slide also I presented it for some conference. So I started my journey with the Saint Gobain Glass in Chennai, and then I came to Coimbatore, set up wind power. And how many of you probably can say the so-called the AI and other things have started from Industry 4.0. So this one Industry 4.0, when it probably came to the research or government's notice or nations started speaking about it. Can you tell which year it is? Anyone? Which year the Industry 4.0 kind of a buzzword started coming to the world? How many of you know what is Industry 4.0? Sorry, professors, just if at all we can have some good discussion, it will be very easy. Otherwise, it will be monologues. I'll be just talking.
Participants, you can kindly interact with sir.
Okay, so Industry 4.0 actually came to the buzzword, or people started talking about it somewhere around 2014. You can see here. Okay, so here we got an award from Germany, and Industry 4.0, by the way, also is you can see their Prime Minister Angela Merkel. She announced it, okay, in 2014. So Germany, it's an happening place for this, and I worked for a German company. That of Wind Power is a German company, and they have 120 different locations where they have plants. They conducted a kind of a competition, and we created a kind of energy management solution where 52 percentage reduction in specific energy consumption. We were able to do it, so we got an award in 2015 when I received that particular award. And when juries are talking about it, they were talking about data analytics. Can you use data analytics further to enhance this particular data? And in 2017, you can see here, it is 2017. Once again, my team got an award for successful implementation of an Industry 4.0 solution with tangible results. Even now, if you go to their website, vision.setup.com, you can see my article, and there is my photo and other things will be there. Then I went into Siemens. I love to contribute my articles, if at all, maybe in a crude way, but at least something will be there for you all. So this is one of the case study where data from a machine we want to take, and with that particular data we want to do some analytics out so that the problems can be solved. Okay, what is the problem? So this problem started somewhere around that 2016-17 period. Okay, the problem is we did one change, okay, in the system. The change is from an induction motor, we converted the fan into a brushless DC motor. So the change resulted in there is a PSG Tech helped me during that time. Dr. Ashok L. Ashok, I was working with him. A lot of computational analysis and other things we did. But finally, the problem is there was one equipment which needs to be maintained because of this efficiency improvement, it has become 5 different equipments. So I don't know how many of you can understand this. Maintaining one scooter or one bike, okay, it's okay. But let's imagine, like, instead of one bike, you are having 5 bikes. It's very difficult, right? First of all, you have to use that particular bike. So every day you have to take it. So that is a kind of a problem. The same way, the problem got amplified. So when 5 missions are there and people have to go there and do that, cross check and other things, what happened is there was a kind of an accident which happened to one of my colleague. Then I want to investigate, as I being the manager. I asked him like why you went. He told like this is the reason, this is the reason. And then I told like, okay, why you have to go there? You can do it sitting at your office itself. Why you have to travel all the way above the roof, going inside that particular air handling unit is an equipment. So that is how it started. It's a very soft issue which has created this particular problem. So I will remove the probably the energy part of it and directly go into the data analytics part of it, which is there in the last slide. Okay, so you can also see like there will be a lot of things. So the problem which we had, one equipment become probably 5 equipment. And by the way, what happened is 100 fans we need to maintain instead of a 10 fans. So that is the kind of a scale. Sorry, 20 fans. So that is the kind of a scale the problem was. So 20 become 100. So almost 5 times. So now 5 times, can I ask the management that you give me more manpower because now more equipments are there? They will not, right? So what we thought is, okay, let's create an industrial Internet of Things. Connect all the fans into a network. Using the canvas, can we collect the data? And with that particular data, can we do analytics so that people should not go there and do anything? So we basically adopted Industry 4.0 during that time. And that is why we got this award. Now, coming back to analytics. In analytics, there are multiple things. First is the descriptive analytics, as you all know, which will tell what happened. Second is the diagnostic analytics, which will tell why it happened. Predictive analytics, which will predict what will happen in future. If you are able to predict the future, if it is saying like something bad will happen, you have to correct it, right? So that is the prescriptive analytics. Descriptive, diagnostic, predictive, and prescriptive. These are all the different type of analytics. So in our case, we, I would say, like, want to go to predictive analytics, but we achieved it. But to some extent, even a prescriptive analytics also came when we tried it, when we attempted it. This is the case study about it. There are a lot of algorithms which we can use. I'm not going into those details. Let's go straight into the use case. So this is the first use case. We collect a lot of data from machines. Very simple. Do a box plot of it. Calculate the interquartile range multiplied by 1.5. If some data is coming outside, call it as outlier. And with that particular outlier detection, identify that there is a bad behavior happening. And with that particular bad behavior, ask the team to work. Instead of checking all the machines every time, every month, we can collect this particular data, and with the data, a condition based maintenance can be created. So in this case, there were 3 CNC machines, identical CNC machines. All have been bought from a single supplier, a German supplier. And you can see like whatever is there in this blue color is the load what that particular CNC machine has to take. We were collecting this data. Suddenly we saw if same components I am going to give to these machines, Same load, almost more or less the same load it is taking. Why only the machine 3 the temperature is high? When we understood, like, there is a coolant blockage, and because of that its temperature is high, then we asked the people to make it ready. People analyzed it, then took some action. Then we see that after correction it got reduced. So this is one of a descriptive and diagnostic analytics, which can also be called as exploratory data analytics. An example for it. Any questions on this? A simple Gaussian mixture model, nothing else. Now, here we want to even predict the malfunctions much early. I cannot only depend on the exploratory data analytics. I have to create a mathematical model. And with that particular model, I need to calculate the theoretical output as well as the practically what the output is coming. But the theoretical output is something as per the manufacturing, it is a fan, right? So this is how the fan goes. Okay. And you can see, like I told, like, there was an accident, right? This accident happened like this guy have to go inside, do all these things, and finally, when he was working in this particular thing, the air sucked and this door actually crushed his fingers. So that's why, we also took it. And can you see, like, what type of work he is doing in a dark room? Okay, so this is the kind of a problem we asked him, that you don't have to do it. You can sit at your office and do all the things. The next important thing is these dampers. This also have to be checked, and sometimes these dampers get stuck up with dust or with temperature change, or sometimes there will be some bird or something which will put something, and because of that it will get stuck. These are all the different problems which we had. Then we thought, like, okay, great. It is a fan. A fan will have a characteristic curve. Let's use this characteristic curve. And with that characteristic curve, let me arrive at the theoretical number. But you can see, like, it is a parabolic in nature. But when we analyzed the data, it is not even parabolic. It was having a very different relationship. So the idea is use a mathematical function. We tried multiple other things, but finally, a very simple linear regression was able to calculate the expected power more accurately than a complex algorithm. Only one small change we did is, with explainable AI, we try to see that which particular initially it was a multi feature kind of a problem. Not only regression, we also tried some decision trees. And when we use some explainable AI packages, we found, like, it is giving a kind of a clustered output, that in daytime the relationship is different, in nighttime the relationship is different. Then we understood, like, okay, now we have to separate the data into day and night, and then let's train it. Once we separated it, we were able to even solve this mathematical relationship modeling using a very simple linear regression. So that's why, there's day and night is there. And the hypothesis here is, if the fan is working as normal, the relationship between the RPM at which the fan is running and the power it is taking will be same. If there is a deviation, and if it is crossing above the limit, when we are comparing the expected power from the highly accurate mathematical model out of machine learning and the actual power from the energy meter, if the difference is more, then you raise an alarm. So we use R for it. We plotted the data, and finally you can see, like, there is an y is equal to mx plus c kind of a relationship we got. And we had the R square, the degree of fitness, and with that we were able to see, like, whether it is fitting well or not. we created some, I told you, no, there is a shortage of data in manufacturing. So what we did is we simulated the condition and created the faulty issues. So this is one where we created a choked filter. That is, instead of the filters which are good, we removed it and we inserted choked filters and collected the data for 2 days. And with that particular data, we cross-checked whether it is giving a different pattern. You can see now the degree of fitness is getting collapsed, not for 14 and 16, but at least for other fans. So this is giving a pattern for us. When this pattern is happening, then it is a problem of a choke filter. So like that, we created a kind of a prediction. So now you can see, like, if everything is normal, it will be like this, and some abnormality is there, then it will throw a pattern, and with that particular pattern, we can identify whether a problem is there or not. Then we created another problem, which is the damper. You remember in the photo we show some damper, right? If the damper is faulty, what happens? That is the next thing what we did. And that also gave us a very good result. A faulty damper is there. It is giving a different pattern. So now you can see, like, this is the damper problem. In the above, this is a choke filter problem. You can see, like, in the input 5 fans, it is different, and the output 5 fans are different for a filter choke condition, and for a damper linkage broken problem, it is different. So with that, we identified, like, if this pattern is coming, then it is a fire damper linkage problem. Even we can find out much before it is happening. Then what we did is, after all these things, we started capturing almost 9 to 10 different phenomena of failure using the data. And we created a kind of a screen where it will be green if everything is okay, and if it is a problem, it will indicate in amber or red. A rack status we introduced, and with that, we were able to identify the problems much in advance. Now, what we also did is we introduced some other problems. For example, unbalancing of the fan. That also we tried, and we were able to simulate it. And this is another problem which came in when we are doing this work. So we collected the data, and with that particular data, we trained the algorithm. And with that algorithm, we were able to predict that unbalanced problem also. So it is a continuous evaluation. Okay. So this is one of the case study, probably a real-time case study for you all to consider. If you're having any questions, we can discuss. Otherwise, we can go to the next use case. Any questions so far?
Participants, if you do have some questions, please do clarify with sir. Either post it in the chat window or I have to unmute you. Since the participant crowd is more, the unmute option will be given only for the people who raise their queries. It's fine. Either you ask me to unmute or put your queries in the chat window. Anything is fine from my end. Please be interactive. Sir, I do have a question. When you apply all these kind of advanced concepts of AI in different domains, like what is the impact that we learn when it is getting implemented at each domain? For an example, when you were talking about implementing the AI concepts in a hardware-based environment, probably we do work with that at a research end, right?
Yes, ma'am. Okay.
So what is the inference that we get when it is applied for the different domains?
So, for example, in the use case what I showed you, where the operator who is going into an hazardous zone, and he is going into a hazardous zone itself is, he is risking his life, right? Though he is taking a lot of preventive measures, there is a chance of accident happening. So in that case, your algorithms will save lives. In another case where you are able to detect some abnormality much in advance using these machine learning algorithms, like identifying the machine, or even there will be some in COVID, there were AI algorithms deployed in CCTV cameras where the mask is something detected, right? So it's all depends on where we are applying these particular technologies and what type of result we are getting. So results, it varies based on each and every use case. The highest result you will get it when you are employing AI in new product development. Using AI, can it develop a new product? The AI algorithm itself can be a product, or for creating a new product, a mechanical product or something, you can use AI. So that is, I would say, like for any organization, the value will be very high because you are adding a product or enhancing a product by which you will have more sales, by which you will have more profit, and it will be a key differentiator. So you will have a bigger market share.
Thank you, sir. I understood like it increases the value of the product when these concepts gets implemented at the real time.
Exactly, ma'am. Exactly.
Thank you, sir. And it seems that there is one other query in the chat window. Recent industrial IoT challenges.
I would say like skill gap is the biggest problem, sir. Because see, I will give you a hint for it. Okay. See, this is my LinkedIn profile. Okay. I'll also put it in the chat. Please follow. You can see here 6 years back. 6 years back, me and my team did this work. This is me, by the way. So we implemented an industrial Internet of Things at Germany. Okay, it is Witten. It's in the Germany steel plant kind of an area where setup was having one plant, and they asked like, okay, you guys are doing IoT, so can you go to this particular plant and do this particular IoT thing? The problem is like we know in this plant in Coimbatore how to connect it to this particular CNC machine and get the data, but they were not aware of it. Now, this awareness problem, what happens is it creates an opportunity for the suppliers to come in. They will say, like, sir, we will get it. This will be the cost. So you need a manpower for managing the project. At the same time, you need money also to buy the license for whatever software they are saying. So there is more cost getting involved. When more cost is getting involved, if the returns are very less, that becomes a very big challenge. But where it starts from skills. So my suggestion would be like wherever I go, be it ZF or be it the current company LG, we see that we are creating a kind of a lab where all these skill problems can be given as a problem data bank, or the IoT use cases can be given as a problem data bank. Try to do an experiment like how you're doing a PhD. Once the experiment is a success, then create a small use case and test it. If it is a success, then try if you can do it for 10 different machines or 10 different devices. Then, it will be a step by step approach. You will be not spending more money. Your management will also be happy. You will also be happy because you will get result. Hope I answered to you, sir. So it's not on technology and other things. It's more on skilling and identifying where to use what. For another use case, I will tell you another live experience. I will tell you is So all these things are very, complex algorithms and other things, but if this algorithm have to work, you need data, right? Data. I don't want to name that company. In my Siemens consulting experience, there was one person, one very big company. They were taking vibration data, okay, and this vibration sensor, what they took is an RMS sensor. It is a root mean square averaging kind of a sensor, and using Ethernet, they were taking this RMS value and they were doing an FFT at a server in the control room. You understand, sir, what I'm saying? So they have killed the data at the sensor level itself. They have averaged it, and then over Ethernet they are collecting it and they are doing a kind of a spectrum analysis of it. How they will get false spectrum data there? If the false spectrum data is not available, how they will be using these kind of algorithms? Again, it is a fundamental skill gap, nothing else, which is the problem for IoT, because IoT is now a very old topic. You can see, like, even my case studies itself is 2016, 2015 kind of. Now, going to probably what I'm doing at LG, I'm responsible for heading, leading these emerging technologies at LG. AI is one of a very important wing for us, identifying the skills and mitigating the skills, helping the people to adopt. See, AI directly we cannot think about, prescriptive and predictive alone. Descriptive and diagnostics is also a very important aspect of AI, right? These are all some of the projects what we are doing. I'll show you some projects. You can see here, this is a shop floor. So this is an experiment what we did. Experiment is success, but patient is dead. That means we were able to do it successfully, but the cost of implementation is very high if you are calculating at scale. So we stopped it. I'll show you what is the experiment we did. It is a simple CCTV camera, and you can see like there is an operator who is coming inside. You can also see, I don't know whether you are able to clearly see, there is a bounding box which is also coming and detecting that there is a device here. And you can see that there is a small bounding box here which says like in which nut they are opening and tightening. Hope you are all able to see it. With all these things, the algorithm detects whether he is doing the job right or wrong. If he is doing the job right, then it is green. If it is wrong, then probably there is a kind of a speaker we had. You can see like now he had finished the unscrewing of the bolt, so it is green. If he is not doing it properly, then there is a speaker there which will create a kind of a sound. The operator will understand like, oh, I did something wrong. That is the reason. It is giving nudge. So I need to see that whether there is a violation of the standard operating procedure or not. It was working very nice for one process. But when we have to replicate it for multiple other processes, we were not able to do it. And for that, the cost is very, very high. We are also using image analytic techniques because the compressors, what we are manufacturing at LG, it is going to 120 countries. Each and every country, different language, different signages, different standards. The stickers, it's not about the compressor, it is about the stickers. What is going along with the compressor is very, very important. The way the nameplate, the language in the nameplate is very important when we are doing business with 120 plus countries. We try to employ how, with image analytics, we can identify whether it is the right image, whether that particular part is there or not, whether the sticker is there or not, before we are dispatching this particular materials to the global. We are also working on generative AI very seriously. The biggest challenge of generative AI is data security because the model is running in the cloud. When we started it, we were exploring the open AI kind of things, but over a period of time, we started, creating our own LLM on-prem LLM, and with that LLM, we started, doing experiments. We compared it with the pricing and other things, and finally, we fixed our own LLM, and this is the LLM what I'm showing based on Llama, the Meta's LLM. As we speak, it is 3.2, sorry, 3.3. We have 3.2 with us, and we are also using Pi models, Microsoft's Pi model, and we are exploring how it can be useful for our manufacturing without any fear of data security, because it is an on-prem within LG. This LLM will work. So generative AI, we are very serious on, and we are also using RAG, retrieval augmented generation, so that the hallucination, that risk can be avoided. And we are using RAG flow for it using the Llama model. So just skip all these things. And we also have something called LG Data Shield kind of a work, where whatever data we are giving to the AI models, especially the co-pilot of Microsoft, we are making sure that sensitive data are not given, because it is anyhow a public chatbot, so we don't want to risk. So this is a kind of an thing of what I mean by sensitive data, which is prices, profit margins, and other things which are very very sensitive, cannot be given there. We are also exploring multiple other platforms where over API we can do data extraction from PDFs. Okay. And many times, though it will be the same, it will be represented differently. For example, reciprocating compressor can be mentioned as recip also, reciprocating compressor also. So how we will be able to distinguish it? Right. So what we are doing is we are also training that these are all the ways these things can happen. And many times these PDFs, what we are able to get it from public network, the tender documents, sometimes the formats also changes. So we are using image-based AI algorithms for detecting it. Invoice processing, how we can automate data captures from invoice and move it into the ERP. AI-based forecasting, especially time series forecasting of inventory, we are doing it. We are also working on other projects like soft sensor development. As I told early, I think the professor asked like where the value will be high. We are exploring how generative AI can be used for research and development, like generative design. So this is one of the exercise what we did. You can see on the left hand side, this is a high volume component. You can see the weight is very high. When we give it to generative design, automatically it is suggesting like this is how you should probably have this particular metal. Now I can create a mold for this, and with this particular mold I can generate it. The weight difference itself is almost half of this. That means half the material cost is getting reduced. That is the direct saving what we are having. This is the before and after generative design. We are using a lot of low code AI platforms, especially Knime, KNIME. Anyone, if you want to adopt it, please do it. It is one of the best platform. Even at Siemens, we used when I was there in Siemens. It's one of a very good platform. Please use it. So this is the short use cases what we are doing at LG. Okay, so with this, probably if there are some questions, I will be happy to answer.
Participants, if you have any queries, kindly do interact with sir. You can raise your queries either posting in the chat window or you can ask me to unmute you. Anything is fine from my end. Please be interactive. Participants, if you have any queries, please do post it in the chat window or you ask me to unmute you. Kindly be interactive.
Fine, Surya madam. Then thank you so much for the opportunity.
It's our pleasure having you here, sir. And as usual, always all your ideas were enriching our research interest day by day, every time when we have a meet with you. And probably, I think it is always online kind of interaction with you. We'll be very happy if we have a physical discussion with you in future, probably in any upcoming advisory committee meetings or anything like that. Very happy to have you here, sir.
Sure, madam. Sure.
Sir, your research topics. Let me share you this. Oh, everybody's thanking you on the chat window, it seems.
Thank you, professors. Thank you so much.
So we extend our heartfelt gratitude to Dr. Somasundram sir for accepting our invitation and always says yes for whatever we ask whenever it is getting scheduled, irrespective of whether it is an academic discussion or research discussion. It's pleasure always having you on the board of Department of Computer Science and Engineering, sir, at PSG.
Thank you, professor. So I think you can see the ambience of the company here. This is a company called Zabia, and they are having a development house here. Let me show you a quick tour.
Sure,
So
sir.
this is where the developers work, and we are developing a software here. And the software development, I hope all of you can see. This is the kind of big process which we are trying to digitize and then improve the process using AI, robotic process automations. So this is the ideation we are doing. So this schedule was suddenly, I have to come to Rajasthan, Jaipur, and along with the dev team, we have to do this. So I have to take some time out from my colleagues and interact with you all. Okay, so eagerly looking forward. Please feel free to get in touch with me. My LinkedIn coordinates is already there, and my WhatsApp number also I'm putting in the chat. Thank you, professors, for your time.
Sir, 1 second. Manoj sir is asking to unmute him. So I'll unmute him. I hope so he has some queries. Manoj. Manoj Yadav, right?
Yes, ma'am.
Please proceed, sir.
Yeah, good evening, sir. Uh, Sir,
Good evening,
actually,
professors.
we want, my question is very basic that how this kind of research can be connected by a teacher like us in our engineering college. Basically, we want to do this kind of stuff, but sometimes we don't have such ideas, sir, actually. And sometimes maybe the knowledge is as per the requirements, sir. So how we can be connected in a such kind of environment and how we can take the things a little bit ahead with our potential, sir.
Uh, Thank you, professor. I think you really nailed it. The biggest problem for us is, identify where we should work. So let me share the window. I'll just show you some of the ways we are doing it. I hope my screen is visible for you all.
Yes, sir. Yes, sir.
Okay. So I'm also a visiting faculty in Amata School of Business. So there I teach the students only one thing: how to identify problems. That's all, nothing else. So there are
Okay, sir.
some very good frameworks which is available, especially when I did my research with the Swiss School of Business. I had a privilege to work with some very beautiful, professors who have a lot of industrial experience, and the biggest, I would say, advantage what we had is the frameworks. I will share you one of the framework. This is the framework which you can use to identify problems. First thing, professor, as I told you, anything without business sense is nonsense. So we need to have idea which has some business value or money value. So picking a problem area, we also have to evaluate how much will be the saving you will get out of it. Second is we also have to see experience value. Can I do something where the user is getting more experience? For example, Amazon, you are buying something. Say the can any of you or Yadav sir, can you say like what AI feature you have used in the Amazon app?
So the recommendations, probably based on the interest or whatever we visit and don't buy it out.
Yes, ma'am. That is obviously, but that is more for their benefit, for our benefit. See, what they are doing is they are recommending something where they are getting more profit. But
Actually, sir,
for
I'm
us,
also working on a recommendation system as well, sir. Sorry to interrupt you, but
okay. So, see, day before yesterday, I stayed in a hotel, and that hotel was having a Gita in their reading table, and it is a very smart, cute book, a small book of Gita. Then I took my Amazon app, clicked circle the photo, and it will find right. So just take a snap of it. Automatically, the AI recognizes that what is that, and it searches in his catalog whether this particular product is there or not, and takes it in the front. It may be 200 rupees. It's not a very big money Amazon got it out of it, but I will not come out of the Amazon app because I know that this is an experience I will get. You got it, Professor. So it is the AI algorithm which is giving a superior experience. That is money, actually. That is very big business. The third one is platform value, where if you are able to connect two devices, the value you will get out of it is so and so. 20 devices, it will be 20 power 2. So it will get exponentially high when you are connecting more devices, more people with your AI algorithm. An example for it is, I don't know how many of you, there is a fitness app called Pacer, Pacer. What it does is, using AI algorithm, it sees in which particular group I have to be there so that I can get more motivated for doing my walking. So what they are doing is they are connecting people. It is not Facebook, it is not WhatsApp, it is only a fitness app, but it creates a network using AI algorithm. And with that, I got a lot of friends actually. So it is the platform value. And there is another very good framework called Digital Piano Framework, which is also something you can use. And this is the digital business strategy kind of a document where you can also use this to identify the cost value, experience value, and platform value. So, Professor, the answer to you is consulting, speaking with whomever is ready to probably experiment with you, uh, speak with them, understand their value drivers, why they are here in that particular business, what threats they are seeing in the near future, and what they want to achieve in next 3 years. And for that, if you are having some idea, maybe AI based or even a small IoT based applications, suggest to them, they will surely take it. So this is the digital piano framework, how to make it happen, kind of thing. Like finally, doing it is very important. You should implement it and get the benefit out of. So if you have to implement, you have to think about not only the digital enabler, that is the technology piece of it. You also have to see the business piece of it, which is the strategy, and the people part of it, because people have to use it. That is very important. So this is another strategy you can use, a framework. This is from IMD, International Management Development Organization. It is a Swiss-based, kind of management institute. This is one of the framework, and there is another framework called Digital Matrix, which can also be used from Professor Venki Venkat. He has a 9-quadrant matrix by which you can identify problem areas. Please get in touch, Professor. If you want something, I can also help you.
Thank you, sir. I think we have two other queries on the chat window. So one from Uday Suryan, sir, asking, is there any collaboration of your company with India?
Collaboration? Sorry? Is
Uh,
there any?
he wants to ask about your company's collaboration with India, it seems, if I'm not wrong.
Professor, ELGI, headquartered in Coimbatore, Tamil Nadu, India. We are having, in India, we are number one in air compressors. Probably you might have traveled in any of the train. If in second class or third class, in the first class, if you have enjoyed the cushion of that compartment, it is air cushion powered by an LG compressor. If you think like the brakes are working in a railway system, that is 85% market share we have with Indian Railways. So it's a completely Indian multinational company with I would say roots from Coimbatore. We are doing business in 120 countries from India, and now just imagine how much will be our GDP contribution. Yeah, I would say like because everything is done in India and it has been exported. 50% of our businesses with abroad from India. So it's a huge GDP.
Actually, he has extended his question like, in what way you can contribute to our country for its growth in AI industry? And that was the intention of his earlier question, it seems, sir.
Again, thank you, Professor. Actually, I don't want to speak about myself, but you are making me to speak. So, see, at LG, or personally myself, Surya Madam also told, I don't say no to any skill development things, be it college professors, students. I work very closely with them. We have an initiative called Digital Innovation Dojo, where at any point of time 40 students will be doing internship with us, and we started it almost 2.5 years back, even before Indian government came up with this Indian internship program. So in that way we feel like we are not probably doing for what India wants now. We are doing something for these students by providing internships and projects, guiding them, mentoring them, and that too giving them a global exposure, because at 28 countries we are having our offices, and these students are not working only for Indian use cases, they are working for global problems. In that way we feel very proud that we contribute to our nation building, and developing the skills and the next generation students. Hope I answered, Professor.
Yes, sir. Is there any other queries from the participant side? And he has answered you. Yes, thanked you for it. Is there any other queries from the participant side? Sir has shared his LinkedIn profile, probably even his WhatsApp number also. So related to any kind of these research related queries, kindly communicate with sir, or you can put as a query to the registered email ID of the FTP, and we will take it forward to sir and get back to you. Thank you so much for sparing your time in spite of all this busy schedule and showing a small tour of the IT industry there. And probably all the audience here are either faculties working in engineering colleges or research scholars. So really, this gave us some kickstart for the next semester also, sir. It's great having you
Thank you,
on.
madam. Thank you so much for the opportunity. Thank you, ma'am.
Thank you, sir. Thank you.
Thank you all. Thank you all. Thank you.
Dear participants, the attendance link of this session will be posted in the chat window, and it will be there for the next 20 minutes. I'm posting in the chat window. Kindly somebody get back to me whether it works for you. Yes. Thank you so much. It will be active for the next 20 minutes.